I was asked to put a screencast together for application exercise 5.3. It's just occurring to me that I'm going to have to figure out a way to share it with you elegantly. But here we go. We've got this Bertrand duopoly where the producers produce differentiated products, but they compete in price. They're Bertrand duopolies. And marginal cost of producing each round of cheese is 6, and the demands are for Francois, Q Francois equals 30 minus Francois' price plus Babette's price. And then Babette's demand is equal to the quantity demanded for Babette is 30 minus her price plus Francois' price. All right, so let's go ahead and solve this. Actually, there's two parts to this. One is just the straight differentiated product Bertrand problem. And then the other one is sort of a interesting question. Is there a first mover advantage if there is a Stackelberg leader in the price setting? And we get sort of a funny answer to that question. I'll get there eventually. One sec. All right, so let's just start with Francois' problem. And his demand is equal to QF. Well, QF, his demand, is equal to 30. I'm going to change things around, plus PB. That's essentially the constant minus his price. So his marginal revenue, for reasons I showed you in class, but I'm not going to hold you accountable for, 30 plus PB minus 2PF. And we set that equal, he sets that equal to 6. 30 plus PB minus 2PF equals 6. And from there we derive Francois', it's supposed to be an R, Francois' reaction function. And I'll let you work out the algebra, but the reaction function for Francois is equal to, let me see, 12 plus Babette's price divided by 2. And it's a symmetric problem, so we know that Babette's reaction function is, she'll set the price that's equal to 12 plus half of Francois' price. And we, just as in the Cournot problem, the equilibrium occurs where they correctly anticipate each other's price, and so that would, the way that the algebraic consequence of that realization is that we can substitute Babette's reaction function into Francois' reaction function to figure out what Francois' price will be, and from there we can calculate Babette's price. So 12 plus 1/2 times 12 plus PF over 2. And when we sort that all out, we end up with Francois' price is equal to 24. Babette's price is equal to 24. And that means Francois' quantity is going to be the same as Babette's quantity, and that quantity is going to equal 30. And so Francois' profits will equal Babette's profits, and that will equal, well, it'll equal the quantity 30 times 24 minus 6, otherwise known as 30 times 18, which is equal to 540. So now we're asked to do the Stackelberg equivalent for the Bertrand differentiated product duopolis. And this, as we saw in class, has a sort of a weird outcome. Let's go ahead and have at that one. So let's suppose that Babette is the Stackelberg leader and that she anticipates Francois' price or Francois' reaction to her price and maximizes accordingly. So before she does any anticipating, that's her demand. But if she anticipates Francois' reaction function, her demand becomes 30 minus her own price plus Francois' reaction to her price, which is 12 plus her price divided by 2. And when we sort that all out, we get the following. QB equals 42 minus Babette's price over 2. And that means her marginal revenue is equal to 42 minus her price. And we set that equal to 6. And it's pretty easy to see that Babette's price will be 36. And Francois just reacts to that, so his price is 12 plus 36 over 2. His price is 30. Plugging those numbers into the demand curves, we find that Babette sells 24 rounds of cheese, and Francois sells 36 rounds of cheese. All right, well, let's look at profits. So Babette's profits are equal to the 24 rounds she sells times her price minus marginal cost, which is 36 minus 6 is 30. And we end up seeing that Babette makes 720. And on the one hand, that's better than when she was a differentiated product, Bertrand duopolis, not anticipating Francois' reaction. But what's interesting is when you calculate Francois' profits, and those are equal to 36 times 30 minus 6 equals 24. And if I've done my multiplication correctly, that's 864. So the leader does better than the case where she didn't anticipate, but the follower does better still. So I don't know that there's a ton of intuition about that, only that in this iteration of the Bertrand model, the Bertrand competitors don't keep undercutting themselves. The leader anticipates this undercutting process and sort of holds the line on her price, letting her rival undercut her, but not following her down not following the rival down the rat hole of successive price cuts to try to undercut the other. So the leader forces the discipline. I suppose it could be looked at as the leader of OPEC, Saudi Arabia, holding the line on OPEC quantities, even while some of the follower countries, Libya notoriously in history, just free ride by letting Saudi Arabia absorb the production cuts, but Libya produces more than their targets and enjoys the high price because of Saudi Arabia holding the line on output and price. So maybe this is the Bertrand equivalent of that, where the leader is doing better herself for anticipating and undercutting the successive discounting process, but the follower does better still.